In this lesson, you will learn how to graph nonlinear functions. You will need the graph sheet that was provided to you as well as notebook paper. So let's first look at linear functions. You should have previously learned about linear functions. They can be written in standard form, slope-intercept form, or point-slope form. All of these type of equations would make a line when graphed. We have been working with nonlinear functions. Quadratic functions is a type of nonlinear functions. When you graph it, it makes this U shape, so it's nonlinear. That U shape is called a parabola. So our quadratics in standard form are y equals ax squared plus bx plus c. In vertex form, we have y equals a times x minus h squared plus k. In order to start graphing a quadratic, you need to find the vertex. That is your starting point, is the vertex. Another nonlinear function we will work with is a square root function. If you will recall, we have previously worked with square roots. Underneath the radical sign, when we had the square root of a positive number, that gave us 12. So for example, the square root of 144 gave us 12. But if we had a square root of a negative number, it gave us an imaginary solution. So when working with square root functions, we're going to have to restrict the domain. So our square root functions are y equals a times the square root of b, that is in parentheses with x minus h, and then the plus k is on the outside of our radical. Because of these real and imaginary solutions that are possible when working with square root functions, we will restrict our domain to be greater than or equal to 0. Again, if we had a positive underneath the radical sign, we could take the square root. For example, square root of 144 is 12. But when we had that negative, it gave us an imaginary solution. We cannot graph an imaginary solution on the xy axis, so that's why we need to restrict our domain to be greater than or equal to 0. And that's going to be how we start our graph, is by finding the domain and going in whichever direction the domain said. When you solve, if it says it's greater than, maybe you solved for a 4, then our domain will be greater than that 4 when we graph it. And notice it's just an arc here. It's not a total U shape. A square root function, you can think of a quadratic laid on its side, but then because we can't take the square root of a negative, we don't see the full U shape. We just see the positive section of that U shape, because this section that would come down here would result in imaginary solutions, and we cannot graph those. Let's look at our next nonlinear function we will work with, is a cube root function. When working with cube root functions, we see that y equals a times the cube root of b times x minus h plus the k is again on the outside. So notice with square root and cube root functions, our variable for x is inside our radical. So of course, if the radical is a square root, it'll be a square root function. If our radical is a cube root, it's a cube root function. And we're going to find that variable x inside of those radicals. For a cube root function, our starting point will be found by our hk. And just like naming hk with our vertex form, we need to be careful with hk for a cube root function. Let's look at our third nonlinear function that we'll work with in this lesson. They are called exponential functions. Exponential functions are in the form y equals a times b raised to the x power plus c. So notice how I'm pointing out that the x, the variable, is in the exponent. Do not confuse exponential and quadratic. Quadratic, you need to see something squared, your variables being squared. Exponential, the x, or your variable, is in the exponent. In order to find our starting point for these graphs, we're going to find the y-intercept. Let's think about a y-intercept for a moment. Let's just look at a graph If I wanted to cross on this y-axis, maybe here, our x value for that y-axis, x will always be 0 in order to cross the y-axis. Even if you wanted to cross maybe down here, for that to be a y-intercept, again, your x has to be 0. So that's what we are going to do with our exponential functions. In order to find our y-intercept, we will let x equal 0. So let's start by looking at some functions. We have our graph sheet. We're going to first start with a square root function. Here we're going to have f of x is equal to 4 times the square root of 3x plus 18, and then on the outside a minus 7. We know this is a square root function because our variable is inside the square root symbol. Well, before we actually start graphing, let's practice finding the domain, because that's how we're going to need to find our starting point, is with the domain of these square root functions. Recall that we care about what's underneath the radical, because if that is a negative number, we will not be able to graph this function. So we have to restrict what's underneath the radical sign. 3x plus 18 needs to be greater than or equal to 0. If it was less than 0, that would give us a negative value. So set it greater than or equal to 0 and solve. We subtract 18 first. So we get 3x greater than or equal to negative 18. Divide by 3. And x has to be greater than or equal to negative 6. There is a rule about flipping the inequality sign, but that's only when you multiply or divide by a negative. Yes, we have a negative, but we're not multiplying or dividing by the negative, so our inequality stays as it is. So this would be the domain of the function. If we were to graph it, we could only pick x's greater than or equal to negative 6. The first graph we're actually going to work with is number 2. It's still a square root function. So the square root of x minus 1, and then there's plus 2 is actually on the outside. My radical's a little bit long there. Plus 2 on the outside. Be very careful that that stays outside your radical. So again, we need to find the domain, so restrict what's underneath the radical sign. X minus 1, restrict it to be greater than or equal to 0. If we had numbers less than 0, we would have imaginary solutions, and we can't graph that on the real coordinate plane. So add 1 to both sides. X is greater than or equal to 1, so that is the domain of our function. So we're going to actually start our graph at that 1. So in your table, put x as a 1. If that is our starting place, we're going to put it at the top of our table. Now all the other graphs, you'll actually put the numbers in the center of the table. But if that confuses you with these, just go ahead and put that in the center of the table. You just might have to extend the table longer, and that's okay. So now we can use our graphing calculator in order to find the rest of the values in our table. In order to use the graphing calculator, always remember to reset. That's the second plus sign, 712. That way there's nothing going on in that calculator prior to you using it that will mess you up. Let's jot that down so you'll remember the calculator reset. It's second memory, which is the plus sign, 7, 1, and 2. And you can just use those numeric keys. So when we start with our calculator, we're going to go to y equals. In the y equals menu, we're going to type in exactly as we see our equation when it's set equal to y. So we have the square root, so that's second square root. Look for that in blue down that first row of buttons. Type in x minus 1, and then be sure to arrow out of that radical. We don't want that plus 2 inside the radical. It makes it very different if that plus 2 is on the inside. So let's jot that down as a note. Here for the plus 2, arrow out of of the radical. When you're putting that in the calculator, make sure that you arrow out of that radical sign. So now that we have our equation correctly put in, go second table and scroll up and down until you find the x value we said we needed to start at 1. I'm actually going to scroll a little bit higher than that, and if you'll notice, here is that 1 that we needed to start at. We have a ordered pair 1, 2, and everything above that gives me an error. That's because if I put in these x values, these solutions would be imaginary solutions. That's why your calculator is giving you an error. So let's go down and find the values that we need. So here's where it's going to be your discretion as to what you graph in these square root functions. If you can, try to find some nice integer values like the 1, 2, and 2, 3, but you'll start to notice some of the values do give you decimals, and it may be required that you graph some decimals, but if we can try not to do that, it is helpful. So jot down your table. We have 1, 2, we have 2, 3. We're not going to quite get these decimals yet because I see this 5, 4. And then let's scroll down and see if we can find any that will fit. 10, 5 will fit. Your graphs are usually a 10 by 10, but I don't want to have to count that far, so I'm going to go up here and go ahead and graph a decimal. Let's do the 7, 4.4. So let's graph this on our graph paper here. So at 1, 2, we have 2, 3, 5, 4, and then 7, 4.4. So I'm right here at 7, 4. To remember to go to 4.4, you're just going to go barely past the 4, almost to 5. So they're about halfway in between because 0.4 is almost a half. So here, in between the 4 and the 5 for the y value. Connect those points with a smooth curved line. And notice because our domain was only greater than or equal to 1, we're only going to go one direction for these graphs. We will not extend this way to the left. Also, there should be no arrow that direction because our domain can only be greater than or equal to 1. So here we have that in this direction. Let's go ahead and talk about the range since we have our domain already. The range is the y values. So in this graph, notice your y values, they only start here at positive 2. And when we look at this graph, all of our y's will turn and be greater than that 2. So we'll say that y is greater than or equal to, because it did have a point at 2, greater than or equal to 2. Let's look at our next function. It's going to be a cube root function. So example 3, we have y equals the cube root of x plus 3. And then on the outside of that, we have the minus 6. Again, we know this is a cube root function because we have the cube root symbol where our x is inside of that cube root. So we need to name our HK point to be our starting point. So always be careful with that h. Remember, we write down the opposite of what we see. For the k value, we write down exactly what we see. So for h, write down the opposite. And for k, write down the exact. So that is going to be our starting point. Because cube root can go in both directions, we are going to put this in the center of the table. And then pick the points on either side. So go back to your graphing calculator. We're going to hit y equals, obviously clear out anything in there from before. We need to get the cube root function. Be careful, it is not an it is not an exponent. This is an index number. So you have to go to math. You can choose option 4 because the cube root is already there for you, or even option 5. So let me show you how option 5 works. So when you select option 5, you actually have to type in the index number to that place. So we want a 3, arrow into the radical symbol, and we want the x plus 3. Arrow out of that, and we want the minus 6. So let's jot down some notes for the calculator. For the cube root symbol, we go to math 4 or 5, and then once again, remember to arrow out of the radical sign for the minus 6. Okay, so in that little spot right there, make sure you arrow out to get that in the calculator. If it was on the inside of the radical, if it's inside that radical, it makes it a very different problem. So let's go second table, and again, let's scroll up and down until we find our HK point. We said it was at -3, -6. This is a good way to check to make sure you're naming your HK correctly. -3, -6 is what it should be. But let's say that maybe accidentally you wrote down the +3, -6. Well, if we go to +3, notice our HK is not showing up here in the calculator. So always go back to your y equals and make sure that is entered correctly, and it is. So second table, it could have been in the case that you named your HK wrong, and that was sometimes the case. So -3, -6 is what it should be. You're always going to have to do the points just one away from your HK, so we're definitely going to want to do the -4, -7, as well as the -2, -5. And then after that, again, we start seeing some decimals. So I do recommend that you scroll a little bit and try to find some integers that graph nicely. We see this -11, -8, but our calculator, our graph is only a 10 by 10. So let's go ahead with a decimal, and maybe let's pick this -7, -7 point, this would round, -7.6. So I'm going to go with that one there. So we're going with this -7, -7.6, because it will round. And then we need to scroll down and find something below the -2. There are some more decimals. Let's see if we can find something that fits nicely on the graph. This 5, -4. It is okay to graph decimals, but with these, if we could try to find some points out further away from our starting point that are nice integer values, that is helpful to graph. So let's go ahead and plot our points. Here we have -7, -7.6. So I'm at -7, -7. If we want to go -7.6, we've got to go a little bit further, about halfway between the -7 and -8, because 0.6 is just barely over a half. So just go halfway between those two. So -4, -7. -3, -6. We have -2, -5, and 5, -4. So notice our points here. When we connect them, they should be kind of like an S shape laid up on its side. So starting at our beginning point, it curves up this way, connecting our points. And then again at our starting point, it curves down this way, connecting our points. This kind of center section looks like they could be linear, a line, but they are not linear. They are not a straight line. Try and curve to connect those points, and then start back here and curve to connect those points. So with these cube root functions, let's think about the domain and range. When we look at our domain, from that starting point, our x's can continue on and on and on and get bigger and bigger. Also from the starting point, our x's can get smaller and smaller and smaller and go in this direction for the negative. So for the domain of this function, we will say that it is all real numbers. And that is always true for a cube root function. The x's and the x's can get bigger and smaller in both directions. So you will always have all real numbers. The range, which is our y values, is actually also all real numbers. I know it seems like it's kind of flattening out, but it is actually growing. It's slow, but it is growing this direction. For the y's, eventually it will reach all of those. It's a slow process, but eventually it continues to grow out that way, as well as in the negative direction. So I know it's a slow process, but eventually it will reach every single y value possible and every single y value this way possible. So again, this is all real numbers, and that's always true. Always true for cube root functions. So domain and range will always be all real numbers. Let's look at our final graph. This time we're going to look at an exponential function. For exponential functions, remember we should see the variable as the exponent. If we're going to call it exponential, that's where the exponent or the variable should be. So we have y equals -2 times 3 raised to the x. To find your starting point this time, we're going to find the y-intercept. In order to find the y-intercept, we're going to let x equal 0. Recall, in order to pass through this y-axis, maybe here at this point, in order to get at that y-axis, that x value would be 0. That's also true maybe anywhere along that y-axis, x will always be 0. So we will plug in a 0. Recall from exponent properties that you've previously learned that 3 to the 0 is 1. We would do exponents first before multiplying. Order of operations says exponents before multiplication, so be careful not to multiply and then do your exponents. So we get -2 times 1, because anything to the 0 power is 1, and then -2 times 1 is -2. So our starting point will be at x as a 0 and y as a -2. Again, put this in the center of your table, 0, -2, because again, exponential functions can grow very, very fast and they can get small very, very fast. So that's where we need both sides of our starting point. So let's go to our graphing calculator. Press your y equals. Of course, clear out any previous functions you have. Type in -2, parentheses 3, close parentheses, and then to do your exponent, you use the caret key that's underneath the clear button. So you press that caret and it raises it to the x power. Then if you needed to, you could arrow out of that and type anything else if you had a plus or a minus number at the end. So here when we go second table, we can scroll up and down and find those that starting point. We see the 0, -2. Before we get our table, let's jot down how we got that exponent. So we would do, in order to do this little exponent right here in the calculator, use the caret key, and that is under the clear button. Alright, so for our table, in this type of graph, you will be required to graph some decimals. There's really no way around it. In one direction, it grows very, very large, so you'll see this -18. We actually won't even be able to reach that on our graph because it's a 10 by 10. And then in the other direction, you'll have decimals. So it is okay that you might not be able to graph all the points that you have in your table, and then the other directions you will have to graph decimals. So let's jot these down to get them in our graphs. So at 0, -2, our next point will be 1, -6, and then 2, -18. Even though this doesn't show up on our graph, it's okay that we still include in our table. On the other side, we're going to have -1 and -0.7. That rounds. The 0.66 will round to 0.7. And then here we have -2 and -0.2. That one will not round. So let's plot these points to form our exponential function. So -2, -0.2, which is just barely below the 0. -1, -0.7, so that's about half between the -1 and the 0. We have the 0, -2, the 1, -6, and then finally the 2, -18 will be somewhere out here, which of course it won't fit, so we're just going to leave it off our graph. Don't ever worry about extending your graph. So let's connect these points with a smooth curved line, noticing that our graph passes through that y-intercept that we found at the beginning, 0, -2, and also noticing how we graph it, the arrow does not pass over the x line. You could always hit the graph button to also compare your graphs. And so if we notice here, our graph looks very similar to this. This line gets very, very close to the x-axis and just continues along beside it. It never actually touches it or passes over it. It just gets very close to that line. And so when you're naming your domain and range, let's first talk about the x's along this direction. For x, I could get I can go in the negative direction all the way out here along this x-axis all the way out to -infinity. If I continued out that direction, this graph would continue going. So I can also go in the positive direction, and it's going to grow very, very fast for our y's, but our x's will continue on and on forever. So for domain, it will be all real numbers. And again, that is true for all exponential functions of the domain is all real numbers. For our range, well, notice our range. We started here at 0, but we didn't quite touch the 0. And we grow and grow and grow on and get bigger. So for our range, we say that the y is going to be, which direction is that? That is going to be, y is going to be less than, because everything down this direction is negative, so y is going to be less than, it will not equal 0. It never actually touches that 0 line, so y is just only less than 0. All of these y values, you can see in your table also, all of those values are less than the 0. So that is how we graph our non-linear functions for this lesson.